management, understand deployments, and how to perform rolling update and rollbacks. So we already saw about how to use deployments in the last video. This time we're going to basically do a number of, create new revisions of this deployment, and then we'll be able to roll things back. So now I guess I just introduced a term called revisions. So what happens is every time you release a new, like you make a change to the pod template to a deployment and you push it out, right? What Kubernetes does is it creates a copy essentially of that pod template and stores it in a revision in an ordered sequence. And those are called the revisions. And what that allows Kubernetes to do is, as you go along, you can then decide, hey, I want to roll back to the previous version of the pod template, and the deployment will push out the old version of the template. Or you can revert back to even an earlier one. Right? There's options to do that too. And so the key observation here is the revisions only maintain pod templates. So as you roll out, maybe you scale up your number of your replicas, that doesn't get stored in the revision. It's only the pod templates. Okay, and by default, Kubernetes maintains 10 revisions in the history, so you can roll back to 10 different, the last 10 versions of your pod template. Now, one bit of confusion here is, if you remember, Helm has a concept of revisions too, which is independent, completely independent. So what we're going to do first is we're going to do our first example without Helm, because I don't want to confuse the revisions of Helm with the revisions of deployments, okay? And then next, after that, we'll see how the two work together. So first thing I'm going to do is create a deployment without Helm, right? So there's a file here called, there's a folder called no Helm, and in this example is basically your deployment, right? Just no variables, right? Because we're not using Helm, and there's 3 replicas of Ubuntu, basically. Okay, so let's deploy this, or install this, or apply this technically. So let's do, so if I do kube control apply -f no Helm, right? And if I do kube control get all, okay, you can see that now I have, the deployment example dev, the replica set, and then of course the 3 pods that are running successfully there, right? Okay, so the next command I'm going to run is to inspect the number of revisions I have. There's a rollout history command. Okay, let me copy and paste it and we'll look at it. So you basically say kube control rollout. So all the things having to do with revisions essentially, all going to roll up underneath the rollout variable, right? So we have kube control rollout history, and then you have to specify it in this sort of lengthy format, but basically the first part says this is a deployment, and then this is the name of the deployment. And you'll see that I have 1 revision, and we'll talk about this change cause shortly, right? So that's that. We can also do command, that basically just tells you how many revisions. You can look at the detail of a particular revision. In this case, I say paste. So it's just basically, you just add a revision number, and then it'll tell you specifically, basically what you do is you can see that basically it's the pod template that was used in a nice, easy to read format. Okay, so that's essentially how you can see what is in a particular revision. Okay. So yeah, so now we're going to look at that. Let's go back to clear. If you recall, there was this change cause. That's just a friendly term that, think of it like as a label that you can tack on your revision, or a name or a description of your revision that you manage manually, and allows you to then kind of give you an idea of, convenient, like what is in that revision, right? So the way you manage that value, and we'll do it through an example, is you add an annotation to your deployment before you roll it out, and whatever's in that annotation, particular annotation, gets used as the change cause. So for example, we're going to roll out a new one here. So I'm going to copy this, and then I'll just kind of do it by example. So we're going to go into this deployment, right? And we're going to add a new annotation. I think it's annotations. And I'm going to paste it in. So it has to be of this format, Kubernetes IO change cause, right? And then this is just a phrase that you choose to put in, right? So that's just a description. And then you actually want to make the change. In this case, I'm upgrading to Ubuntu 2004, okay? So now that I've got that change in place, what I can do is I can do, I'll just type it out. So kube control apply -f no helm. Okay, so that should now trigger deployment. So if I do kube control get all, I can see there's probably a new, it's already happened here, right? Basically, I've already deployed the new versions of the pods. There's my new replica set, right? And everything's already rolled out. So it happens so fast I can't even monitor it. But let's look at now the command, the rollout history, right? And now you'll see now that there's 2 revisions, and now the change cause got described, whatever that annotation was is what became the change cause. It becomes a convenient way to figure out what's in a particular revision, right? Now the key here is you got to make sure you update that change cause every time you create a new revision. Otherwise, it's going to always say upgrade to 2004. Whatever happens to be the annotation is what you get there. Okay, so let's continue. Okay. Oh, so we're going to create another. So those are examples of successes. Let's look to see what happens when something fails. So what I'm going to do here is go back into my deployment template, right? And I'm going to say upgrade to bogus. So this is a clue that something might be wrong. And then I'm going to put in here Ubuntu bogus. So this is not a valid tag for that Ubuntu image, right? So I save that. So let's deploy this and see kind of what happens, right? And how do we detect that there's a problem? So apply it. So looks good. At least it configured it. Let's just do my kind of gut check. Control get all. So what you're looking at here is you'll see I've got the 3 running from before, right? And then all of a sudden I got a pod now in a weird status, right? It's not ready. And then the replica set, I can see the new replica set got created, but it's really, none of them are ready. And you can see that on the deployment, there's 3 available. Those are 3 original. And then, but there's only, one is sort of up to date, but it's actually broken, right? So there's something odd going on here. Okay. In fact, you can do kube control describe deployment. I didn't give a name because I was, being shortcut. You can normally give the name, right? So you can see the reasons here. You can see it's done everything, but let's look at the conditions, right? So you can see right now it's still progressing. It's still trying it's still trying to trying to deploy that one that keeps on failing, right? And what we do is I'm going to pause the video. I think it's like a minute or 2, and we'll watch this status here progressing, and we'll get a clue that this thing has stopped deploying it, right? So you can see right now it says there's 3 desired, 1's only been updated, there's 4 total in play, right? And 1 is still unavailable. So you can see that this thing is still playing out. So I'm going to pause it. I'm going to try one more time just in case it's already done, but I don't think it is. Yeah, I'm going to pause it for a minute here, and then we'll see when this thing stops progressing. Okay, we're back. Just one quick observation. If you get the full output of that deployment, you will see there's a value called, under the spec, called progress deadline seconds, and it's set for 600 seconds, which is 5 minutes. So basically that's how long it takes before the deployment decides that, okay, it's going to stop trying, right? So that's why I had to wait some time. So now that I've waited clearly over that much time. If I get the describe the deployment now, I should see a condition that should tell me there's a problem, that it stopped trying. So let's see. Yeah, so progressing is false now, and progress deadline exceeded. So essentially it's now, you can tell it stopped trying. And you can still see, basically it's in the same state it was previously. Oops. I basically have one image that's stuck, one replica set that's stuck, and the deployment's essentially, it's going to basically stop trying now. Okay, now you don't necessarily have to stop trying to roll back. I just wanted to show that there is a concept of the deployment basically stop trying. Okay, so what we're going to do now is we're going to do a rollback, right? So we know that the last version, let me do this here. So if I go back in the history here, if I can find it, roll out history, right? So you can see that I want to roll back to 2. So what I can do is if I say paste, cube control rollout, right? Undo, and then that deployment. And if I give a dash, so you can do an option with a dash 2 revision equals X if you want to roll back to something other than the previous one, right? And then you can roll back. So I'm going to roll back like this, and roll back, and see, let's look at now, see what's happening. Cube control get all. It's probably already rolled it back. You can see now that I have basically looks back like it was earlier. And if I get to describe the deployment, cube control describe deployment. And again, I'm not giving a name because I'm trying to be quick, right? I only have one deployment. So you can see the conditions. Where is the conditions? Describe deployment, pod template conditions, right? Progressing true, new replica set available. I thought it would be done by now. Let me try it again. I thought new replica set available. I guess it's interesting. Maybe I was expecting progression to say false, like it's done, but you can see that control get deployment. Let's see what its status is. Basically, 3 are ready, 3 up to date, and 3, so it's basically, to me, it looks like it's done. So either way, the point is it's not in that failed state anymore. And if I do the history now, let's see what the history looks like. So now I see a history. It essentially added a revision now, 4, and then it uses the same name it used for that it had for that one, right? Now, interesting enough, it actually seemingly deleted revision 2 because it's basically a duplicate of revision 4. So that's I was a little surprised by that. I would have expected still see 2 there, but either way, it's created a new revision, and it's back to where it was. Okay, so that was kind of the whole rolling out, deployments, right, or like new revisions, and then we rolled it back. Now, so I'm not going to do this on screen, but here's the deal. So far we've been doing everything without Helm, right? We've been using cube control apply. Turns out that if you use Helm and you deploy or release new versions of their chart, right? It actually plays, I guess I'll describe it as saying it plays well with deployment revisions. And what I mean by that is, as you use Helm to do everything, your end result is exactly the same when you do a Helm undo, right? Or when you roll back a Helm revision, right? Essentially, it does the same thing as what we just did in our example, where it actually causes the deployment itself to roll back, right? Which is anyway, I was a little surprised by that, but it actually does the right thing. Now, the easiest way of seeing this is I'm going to replicate everything off screen, right? I'm going to install dev. I'm going to make the image Ubuntu 2004. I'm going to do the bogus thing, right? And then I'm going to use Helm rollback, and I'm going to then observe what the final state looks like. And I'll share that with you, right? So you can do this on your own if you look at the script. So let me pause the video, do everything off screen, and I'll show you the final result. Okay, we're back. So I just did off screen, essentially recreated the installed initial version of Ubuntu 18.04, upgraded, deployed a new version to 20.04. Then I tried to upgrade again, but this time I upgraded to a bogus tag name, right? And then I rolled back to the 20.04 version, right? And so if you look at the Helm, but I used Helm to do everything. So I didn't do any kube control, I didn't use any kube control command to do any of that. And you can see here, there's the initial install. There's the upgrade to 20.04. This is the upgrade to bogus. That's when I observed there was a problem. And then here's my rollback to back to the previous version, which was version 2, which was the 20.04 version. Right? Now, you can see what this looks like from a deployment perspective. So I'm just looking at the rollout history, right? And the key thing here is I can essentially have the same end result as what I did without Helm. That is, it actually shows, the revision 4 actually shows as a rollback, not a new revision completely. So Helm actually did the right thing by when it deployed when I did its rollback, it actually caused a rollback of the deployment revision, which again was surprising, but was good. Okay, so that's it for that topic. This is a sort of a couple one cleanup thing with deployments. Oftentimes you hear about things called canary deployments. And essentially what that amounts to is you may want to maintain at one moment different versions of your application. And so the way you can do this is, basically key is you're going to actually create, let's say you want to have 2 different versions out there, right? What you actually do is create 2 separate deployments, right? And you can scale them up however you want, right? And the trick here is each deployment needs their own set of labels to maintain their pods, right? So you do that just like you would normally do, completely independently. So different set of labels for each deployment. But because you want to treat the whole set of pods as a unit, you use a common shared set of labels separately than the deployment labels, right? To then group all those pods together, and then now you can treat those pods as a singular group, even though some are coming from one deployment and another coming from a different deployment. So that's just I don't have an example of that, but that is a pattern you can use. And it's not necessarily uncommon. Okay, this is a completely kind of off-track thing, but it's still on the whole category of controllers, and we really want to wrap that up. And this is called jobs, right? And so so this is kind of a mental shift. So here, if you recall, right, if you have a single pod, right, and you have a container in there, you can set a restart policy, for example, of on failure, right? And that pod will keep on trying to run that container until it's successful, right? So that's one way of having sort of like a job-like activity, right? But there's a problem, is what happens if the pod itself gets destroyed or deleted because maybe the node went down, right? If say it's a long-running process, right? So this is not going to be, just using a restart policy on a pod is not sufficient, right? And so the higher level object is called a job, which manages a pod, right? And essentially allows you to ensure that in the end, make sure the pod is successful, which means essentially that the container was successful, right? Now, there's different patterns here. Actually, let me just do an example first, and then we'll talk about like some patterns around this. So the simplest pattern that we will do by example is we're going to have a job that runs a single instance of a pod, which has a single container in it, and it just makes sure that it gets done successfully. And so let's look at this example first. Okay, so let me open up the example. So it's under job success. And I'm looking at the template. So the key for a job is to look at the structure. You got basically a different API version, you got the job, metadata is metadata. The spec is basically a pod template spec, right? And the key here is the restart policy of the pod itself, right? Needs to be either never or on failure, right? Because we're really expecting these containers, and thus the pods, to like have an endpoint at some point, right? So you really want one of those two. You don't want always here, because that's really not the right pattern for jobs, right? In this case, I'm just basically running Ubuntu and echoing hello, and I'm actually saying never. So this what will happen is, if should this pod container fail, it just exits, right? And we'll look at the next example for failures, but anyway, that's what's happening here, right? So let's run it, and then let's observe what the result is, right? So clear my screen. Helm, do I have? Oh, I have to delete the old one. Helm, delete, dev. Okay. Just so it's not confusing, I'm gonna let this play out for a minute, so I have a clean setup, and then we'll do our work. So let me pause the video for a second. Okay, we're back. Yeah, so now I just did a kube control get all, make sure nothing was there. Okay, so now I want to do a helm install job success, dev job success. Okay, and if I do kube control get all, just to get a summary of everything, that's what we have here. We have a job. Okay, there's a job. Its completion's 1 of 1, right? And you can see there's a pod that's completed, right? So this looks all good. Let's get more detail about this job real quick. Describe job. Oh my goodness. Third time is it? So I see events here, and I can see that 0 is running, 1 succeeded, 1 failed. This completion's 1 here is basically means this is essentially saying that I want to make sure at least I want to have 1 completion, right? We'll talk about these two in a minute here. One thing I don't really see here is any flag saying that necessarily this job is done, right? I can infer it based on the completions, and then that 1 succeeded. That essentially means it's done. Now it turns out if you do get job out YAML, again, I'm not specifying the name of the job just for convenience. There's actually in the status, there is a condition here, and if you remember, conditions are usually kind of ways to get detailed statuses of where that object is, and you can see that its type is complete is true. So this tells you that essentially it's done. So this is probably the most clear way of seeing that what the status of the job is itself, is by getting the full output. Okay, but you notice that even though that one thing to notice here is even though the job is complete, you notice that all the objects still exist. That's partially because you might want to get logs out of the pod, right? So that's why it doesn't like auto delete everything, right? So kube control like get, let's see, logs, and then I can name the pod, for example, and I should get that hello out of it. And there's a hello, right? And then if you delete, just so you know, if you delete the job, it will then, just like everything else, it'll delete the pods it created, right? Now let's go ahead, but we're just going to get rid of the whole thing. So let's do helm uninstall dev. Okay, and then we're going to look at the failure example. So now just a side note here real quick. So what we just saw is an example of a non-parallel job where there's only basically 1 pod that's created, and that's it. There are other patterns. One is called the fixed completion count pattern. So this is where you set a completion number to higher than 1. So it'll start a whole bunch of pods in parallel, and then it waits to see for how many, it's waiting for a certain number of completions before the job is marked complete, essentially. Okay, so that's essentially the fixed completion pattern. And then there's another pattern which is more complicated called the work queue pattern. And I'm not going to get into detail of that, but that's where you set the completions to 1, but then you set a parallelism number. And basically there's much more complicated. You have to manage, your code needs to decide, your pods need to decide when they're done, essentially. So I will leave that out of this. We're not going to have an example of that. But let's go look at what a failure looks like, and let's see why it's going to be a failure. You can kind of predict it. If I go to job failure, it's the same, essentially the same job, right? I use the same job. Now there's two things I changed differently here. One is I made the container fail because the command is called bogus, so that will never run, right? And I still have a restart policy of never, so that pod will run the container. It never tries to restart that container. It will just fail, right? Now the key here is I also set a backoff limit. The default is 6, I believe. So what this basically means is this job will try to recreate that pod 3 times, and it will actually create 4 times, because the backoff limit means it will if the number of failed jobs exceeds not equals to exceeds this number, then it'll stop, right? So this is going to just basically sit here and try to create jobs 4 times and then stop, because 4 will be greater than 3. So let's just see what happens when I run this thing. Helm install job failure. Oh, keep on forgetting. Dev job fail. Control get all. Let's see what it's doing here. So you can see already it's already tried to create 2, right? So basically it has no completions, right? And it's tried now 1, 2, and then let's see, there's a third one done. Now what you'll notice is that they don't all happen immediately, and that's because there's an exponential backoff process where it will wait for a while for each one, right? So that's why you don't have all 4 done, right? Okay, actually now it's already tried all 4 now, right? So boom, boom, and then it waited a little bit for the third one, and then it waited a little bit longer for the last one, right? So now we're at the point where it's tried 4 times. Now, so let's try to look at the detail of this one now. If I do control get job, let's see what the job looks like. There's 0 completions, but we can do describe job. Let's see to get more information. Here again, we see there's the 4 tries. You can see that there was 3 failed, right? It's sort of 1 still in progress. I think the other one should have failed by now. Let's see. Oh, 4 failed now, right? I guess it just finished. So what's not clear to me, now I can tell from here because I've set in the spec, I've set the number of, I don't even see it here. I set the number to 3, and I know that's 4's failed, so I know this is essentially done. So again, in order to get the details of this, you have to do get job. You can actually see this static conditions here, right? And you can see now, you can see that 4 failed, and then the spec actually had, where's the spec? A backoff limit was 3, right? Because 4 is bigger than 3, this triggers the condition of a status failed being true, and backoff limit exceeded. So this seems to be the easiest way of seeing like really what's going on by getting the full output of the job. Okay. Okay, so that's jobs. Helm uninstall dev. Okay, what's next? Okay, so last one is, we're not going to do an example of it, but so that was a job. It only runs once and you're done, right? Now, maybe you want to do a popular pattern is, you want to do jobs on a time schedule, and that's called a cron job. It's used in many different environments, right? And I think that, Unix is like kind of the history of it, but basically you want to, the structure here is you create a cron job, which involves creating a schedule, which is like, how sort of timing, right? And then you just create a job template, which refers to a job that it will create, right? So cron jobs manage jobs, and then jobs manage the pods.